Have you ever stared at a screen full of code and just thought, wow, that looks like a secret language for geniuses? Well, let's pull back the curtain on that. We're not going to turn you into a pro coder in the next 5 minutes, but we are going to show you that all that complicated-looking stuff, it's actually built on some really simple, logical ideas. All right, let's get into it.
Honestly, the best way to wrap your head around programming is to just think of it like you're writing a recipe. It's really that simple. You know, when you make a cup of tea or some instant noodles, you follow a set of steps in a specific order. Well, programming is the exact same idea. It's just giving your computer a very clear, step-by-step recipe to follow. So that's really all a computer program is at its heart, a structured list of commands. It's just a very formal recipe that tells the computer precisely what it needs to do, one single instruction at a time.
And I mean every program, you know, from the calculator on your phone to the most massive, complex video game you can imagine, is built up from these individual, simple instructions. Each line of code is just one small, totally manageable step in the grand recipe.
Okay, but what good is a recipe without ingredients, right? You need your flour, your sugar, your eggs. In the same way, a program needs data to work with. Things like numbers, or text, or other pieces of information. So, where does a program keep all its ingredients?
Well, we store them in something called a variable. And the best way to think about a variable is to just picture a labeled box. That's all it is, a named storage container sitting in the computer's memory, waiting for you to put a piece of information inside it.
Let's make this real. Take a look at this line of code. This simple instruction is basically telling the computer, hey, I need you to create a box, label it age, and just so you know, it's going to hold a whole number. Now, put the number 22 inside. That's literally all that's happening.
And here's the cool part, the reason it's called a variable. It's because the information inside that box can vary, it can change. Just like you can swap things in and out of a real box, you can update the value. So 2 years later, we can just write a new line that says age equals 24, and the computer just swaps out the old number for the new one in that same age box.
Okay, so we've got our ingredients tucked away in their little boxes, our variables, but a recipe is way more than just a list of stuff, right? It's about what you do with the stuff, the chopping, the mixing, the baking. So how do we actually perform actions in our code?
In programming, there are pretty much two main ways to get things done. First up, we have operators. These are the super simple symbols for doing basic stuff, like the plus sign for addition or the star for multiplication. And then we have functions. Think of these as pre-packaged mini recipes that somebody else already wrote to do a specific job, like printing some text onto the screen.
Here's a perfect example of an operator in action. It's really straightforward. We're just telling the computer, hey, make a new box called sum, and for the value, I want you to put whatever 10 plus 5 is inside it. That little plus sign is a direct command to do the math. Simple as that.
And now, let's look at a function. This one, printf, is kind of famous in the C language. Using it is like shouting to the computer, hey, go run that pre-written recipe you have for printing stuff and use hello world as the ingredient. And just like that, the text pops up on your screen.
All right, this is where programs go from being a simple, straight-line recipe to something much, much more powerful. Because the best recipes and the best programs can make decisions and repeat steps based on what's happening.
Think about it in real-life terms. You might think, okay, if it's raining outside, then I'll grab an umbrella. Else, I'll just wear my sunglasses. See? That's a decision. You check a condition, is it raining? And depending on whether the answer is true or false, you do one thing or another.
And this is exactly what that logic looks like in C. We're asking the computer a direct question. Hey, look inside that age box. Is the number in there greater than 18? If the answer is yes, if it's true, then it runs the code to print adult. This is how programs can react and behave differently based on the data you give them.
Now, what about repetition? What if your recipe says to stir the soup 50 times? You're not going to write the instruction, stir the soup 50 times in a row, right? That would be insane. And that's exactly what loops are for. They are the programmer's absolute best friend for automating repetitive tasks.
Just look at how much power is packed into this one line of code. This for loop is a super compact instruction that basically tells the computer, hey, I need you to count from 0 up to 4. And for each of those counts, I want you to run the printf function with hello. And the result? One line of code does the work of 5.
Okay, so let's take a step back. We've written our recipe. We've got our ingredients stored in variables. We have our steps using operators and functions.
We can even make decisions and repeat things with loops. But how does this text file we've written become an actual program that our computer can run? How do we get from the written recipe to the finished dish?
The magic ingredient here is a special program called a compiler. You can think of the compiler as the master chef. It takes your recipe, which you wrote in a language that humans can understand, like C, and it translates the whole thing into the only language the computer's hardware actually gets: raw machine code, basically a bunch of ones and zeros.
So the whole workflow, from your idea to a working program, just boils down to these 3 simple steps. First, you write your code in a source file. Second, you feed that file to the compiler, which translates it and creates a new executable program. And third, you just run that new program and watch it do its thing.
And you know what? That's really it. Those are the fundamental building blocks of almost all programming. You store your stuff in variables. You perform actions with operators and functions. You control the logic with if-else decisions and loops. And you make it all work with a compiler. Everything else is just combining these core ideas in bigger and smarter ways.
Just think about it for a second. Every single app you use every day, every website you visit, every game you play, at their very core, they all started with these same simple, logical pieces. The entire digital world is just built by combining these little blocks in more and more creative ways. So now that you know the basic ingredients, the only real question left is, what recipe will you write first?